And welcome to today's webinar, Hibernate in Complex Projects, Can We Be a Little Faster? My name is Markus Eisele. I'll be your host today. This is already the fourth webinar in our developer series, and I'm more than delighted to welcome Torben today. So let me briefly introduce, I could say we're friends, right, Torben? So we met a couple of times already. And thanks for joining us. So you're one of the first non-Red Hatters talking on this webinar series. And you specialize in Hibernate, right? So you are the famous author of a book that is called, let me take a look at my notes, Hibernate Tips, More Than 70 Solutions to Common Hibernate Problems. And you've been around JPA in particular and Hibernate and Java since a while already, right? So it's a delight to have you here. Thanks for taking the time. But before I hand it over to you, I definitely have to look after a couple of housekeeping items. And yes, I'm reading them. So first and foremost, today's webinar is going to be recorded. So if you check back on the website in, let's say, a couple of days, you will definitely be able to access the recording and the slides. And if you have any questions during this webinar, please feel free to ask them. And there are actually two ways you could do this. Either add your questions to the Q&A panel or use the chat in the middle, like this nice little window. I'll do my best to interrupt Torben whenever there's a nice question that I can ask. Otherwise, I'm probably just going to interrupt you anyway. So just another, let me rephrase, call to action: be active, be here with us, ask your questions. Ideally related to Java, containers, Hibernate, JPA, whatever comes to mind. Torben, without any further ado, I'm not going to steal another minute from you. Stage is yours. Enjoy.
Thank you, Markus, and welcome everyone to my talk, Hibernate in Complex Projects, Can We Be a Little Faster? Yeah, as Markus already said, well, I'm basically solving Hibernate in JPA problems for a living. And if you want to reach out, discuss problems, or learn more about Hibernate, feel free to visit my site, torbenjanssen.com, or ping me on social media. Yeah, that's all about me for now. Let's dive into the topic. If we are using Hibernate in complex projects, one of the things that always comes up is performance. If you discuss at the coffee corner in your office and you have someone who doesn't like Hibernate or JPA, then they often say, yeah, it's too complex, it's too slow, and that's just because of the framework. And that's, in most cases, totally wrong. Hibernate can be fast. You can use it for high-performance applications, and you can use it to model complex domain models. And in this talk, so in the next about 55 minutes, I will share a few things with you that show you what you need to take care of if you want to ensure that your application performs well under a huge load, and how you can find out what's actually going on within your persistence layer and why Hibernate acts as it does. So when we are talking about performance, especially in the context of this talk, then my main focus is on a few things. First of all, I want to find performance problems as early as possible. And that means before they show up in production and cause issues. And to be able to do that, I will first share a few information about common performance problems with you and show you how you can let Hibernate tell you what it's doing internally. And that helps you to analyze the application while you are developing it and to find the performance problems before they show up in production. And well, after you found them, you obviously need to fix them, right? So that will be then the main part of the next 50-something minutes. Yeah, let's dive into the first question. How do we find out what Hibernate actually does internally? And there is a component that's deactivated by default, and that's called Hibernate Statistics. And you're probably not surprised if I tell you that Hibernate actually knows pretty well what it's doing, right? I mean, Hibernate generates the queries, Hibernate decides when these queries get executed, and the only thing that's missing from most developers and projects is that we, as the developers, don't have this information. And with Hibernate Statistics, we can see them at the end of each session, and we can compare it with what we expected. So to get the Hibernate Statistics, you first need to activate them, because by collecting all this information actually isn't for free. It takes some time. So Hibernate deactivates its statistic by default, and you can activate it using the Hibernate.generateStatistics property. In general, I recommend to use to set it as a system property on your development and maybe a few test systems, just to make sure that you don't deploy it to production. So better not add it to any configuration files. And then you also should configure the log level for org.hibernate.stat to the level debug. Before we get into the IDE, I would like to learn who of you already knows about the Hibernate statistics. Please write in the chat, tell me, do you know this feature? Do you use it or not? Will be interesting to learn. Okay, let's dive into the IDE. Here I took the easy route, especially for workshop presentations and talks. It's better to be sure that the statistics property is activated. So I set it in my persistence.xml file. As I said, I would recommend to set it as a system property, not here in the configuration. And I also activated the debug logging. And if you then take a look at this test case, you can see that it's actually pretty simple, and we will use it to see how the statistics work and what we get from information point of view there. So I select all authors, and then I write out this log message. So the toString of the author entity, and then I count the number of books this author has written. And if we have this in our code, that doesn't look like a big deal, right? I mean, just a few lines of code, pretty simple. But you can see the issue here. We have one line of code here. We have one query in our test case, and we find 12 JDBC statements in our log file here in the statistic, because this is the statistics block that Hibernate writes at the end of each session if you activate the statistics component. So you can see number of JDBC statements executed, time spent on that. Did we interact with the second level cache or not? Did we use JDBC batches? How many flushes did Hibernate trigger? How long did that take? So you can see here there are enough information to get at least an overview of what's going on. To make it a little bit more interesting and useful, you have to activate the log level as I described earlier. And you can see that up here, the log that's the log message that you then get from Hibernate, and that is the query that I executed, the time spent on that, and the number of rows returned. And that immediately shows you, okay, there is this one query, and well, do we have a performance issue with it? Do we not? You can see it immediately here in the log file. So what I recommend is activate the statistics for all of your development systems and double check the statistics summary at the end of each session before and after you work on a new feature. So if it's an existing use case, check how many queries you do before, how you interact with the cache, and then double check how your changes affected it. That at least gives you a good idea of what's going on internally. Okay, I see in the chat that a few people already use it, but yeah, only rarely. And someone wrote that the aggregate view doesn't help him to find a specific issue. Yeah, that's right. It only tells you there is an issue. It's the first step in our analysis. But I prefer to get this statistics during development and recognize, oh, there is an issue with my use case, and then I can start developing, compared to I have no clue if there's an issue or not, deploy it to production, and then my phone rings and I actually learn from the end user or the customer that there was an issue, and I get to hear the complaints that since the last update, the application is actually not usable anymore. Okay, so after we saw the statistics and learned that there is actually a way to learn what Hibernate is doing internally, let's now talk about the typical causes of performance problems. And I want to keep it really short because we just have a little bit less than an hour for the whole talk. The typical causes for performance issues are inefficient mappings. In general, Hibernate mappings are very efficient, but there are a few things and pitfalls that make them not as efficient as we would hope for. Then there are, of course, slow select statements, as with any application that uses a database. And then wrong fetch types. Fetch types describe how, and especially when, Hibernate fetches associated entities when it loads another entity. And, well, unfortunately, even about 20 years after the first release of Hibernate, the wrong fetch type is still a common reason for performance issues. So we will briefly talk about that. And then we also have the situation that we quite often load the same data over and over and over again because we're using the application with multiple users in parallel, or we developed a modularized application and each module gets the information it needs. So in the next about 45 minutes, I will show you different ways to address all of these performance issues. And if you activate the Hibernate statistics to begin with, then you will hopefully recognize that you have one of these issues and find out during the further analysis which of these issues actually causes your problem. Okay, let's talk about inefficient mappings first. There's a bunch of things we could talk about when we are talking about mappings. As I already said, in general, Hibernate's entity mappings are pretty efficient and they work really well. But there is one pitfall that I see over and over again in client projects, and that is the handling and mapping of many-to-many associations. For us Java developers, it's totally fine, and most often the first thing we would think of to model some kind of collection like a many-to-many association as a list, as a Java util list. Because we know from a Java point of view, the Java util list is more efficient than a set, for example. Well, unfortunately, that's not the case if you're working with Hibernate, because Hibernate maps a list for a many-to-many association really inefficiently. If you change something in that association, and we will take a look at that in a few seconds, then Hibernate removes all entries from the association table and re-adds all entries that are currently part of that list. So that means if you have 20 elements in the association and you remove one of them, then Hibernate removes all 20 and re-adds the 19 remaining. That's, of course, not what we expected. And it's easy to fix by just switching it to a set. And yeah, from a Java point of view, the set is a little bit less efficient compared to a list. But in the context of Hibernate, and especially in the context of mapped associations, the inefficiency of a set almost never shows up because you don't have that many elements in a list. And I see just in the chat that was a question, is this also true for a one-to-many association? No, not in general. But there are a few other reasons why you should use a set there as well. So if you want to do multiple join fetches or join multiple association in an entity graph, you would need to use a set there as well. But that is a topic we will cover later in this talk. So what I'm showing right now is something that only occurs in many-to-many associations. So let's take a look at this. So I use a very basic domain model here with authors and books. So if we take a look at the author entity, then we have a many-to-many association between to the author entity. I mean, a book can be written by multiple authors, right? And each author might have written more than one book. So that is a typical many-to-many association. And we have it here as well as a many-to-many association. So let me change this to list, and let me show you the issue that we have done. This is a list. This is an array list. And we need a few imports. Add one. And then there are a few methods down here that need to be adjusted. Okay, done. Now we are done. Okay, if I now go into this test case, if I now go to this test case, get the book with ID 1, and then remove the first author from the list, then we can see in the log file what Hibernate actually does. For removing one element, we just see up here that we got the book, we got the author. That's the typical stuff we would expect because we get both two entities, right? But then we see this delete statement. So we delete all records from the book author table, which is the association table that maps the many-to-many association. And we remove all elements with a book ID. And well, in this case, the book was written by two authors. So due to that, we are re-adding the one author that is still associated with the book. This gets even more problematic if you have a bigger association with a few hundred elements, for example. So let's take back these changes here and switch it back to set. And if I now run the same test case, then you will see in a second, here it is, that we are now just removing the one record from the association table. That's the association we actually want to remove, and is the one where the book ID and the author ID are equal to the one that we provided by here. So small change in our Java code, huge effect on the persistence layer. To sum it up, whenever you're working with a many-to-many association, please use a set, don't use a list. Okay. Next topic, slow select statements. So slow select statements are not a Hibernate or JPA specific problem. Whenever you're working with a database, you have slow queries. And because of that, all database vendors have tools for that. You can analyze your query, you can find out what's going on in that case, and then you can fine tune that query. And if you do that together with a DBA, then you will sometimes get back a query that's, well, not exactly the one that you provided. It might look very different to the one before. And then you might wonder, how do you translate that into JPQL? Well, you actually don't need to. You can use a native SQL query, and that enables you to run a plain SQL statement within the Hibernate context. And Hibernate doesn't analyze that statement. And due to that, you're not limited to the features supported by Hibernate. The only downside of this approach is, well, with a native query, you don't have a lot of mappings or mapping options for the result set. By default, you just get an object array with a field for each selected column in the statement. And well, you can then either map that programmatically, or you can use an SQL result set mapping. And I will show that in a second. But before that, I want to quickly answer Werner's questions about ordering in sets. And if using a tree set, for example, is still efficient, you should not order your associations. The only exception would be if all of your use cases, and I'm talking about all, not most, all of them, require the same order for an association. And that's almost never the case, at least not in regular business applications. If you need the association in a specific order, please use a query with an order by clause. Okay, and the question from Ingo, why Hibernate isn't handling the list any better. That's something we would need to discuss at the end of this this talk. That would get a little bit too long right now, but I will keep that in mind and get back to it later. Okay, so I just said that Hibernate returns an object array for your native query reside. And there are multiple things you can do. If you're selecting all the columns mapped by an entity class, then you can just reference the class of the entity to which Hibernate shall map the result as the second parameter, and then you get back managed entities. So Hibernate basically applies the same result set, the same mapping to the result set as it would do if you're selecting a normal entity using Entity Manager Find or JPQL query. That's pretty simple. But then we have these DTO values, or view values as they are quite often called. And these are way more efficient for read operations. And what we would do there in a JPQL query is we would use a constructor expression to tell Hibernate to instantiate an object of this class when returning the object, the result set. And we can do the same with an SQL result set mapping. In this case, I called it book publisher. And if we now take a look at the book entity, you can see the mapping here. So I use a SQL result set mapping annotation to define this mapping with a unique name. And then this constructor reside annotation to define a constructor call, which Hibernate will perform for each record in the result set. So I tell it to instantiate the book publisher value object and provide the title and the name as constructor parameters. And if you look here, this is the title, this is the publisher. And then we get back one or more book publisher value objects. These are unmanaged objects which are very efficient for read-only operations, and you can then use them in whatever way you want in your business logic. And it should be obvious, these are way more, way easier to use than an object array. Okay, so we now had a look at one of the most common pitfalls when mapping, when creating your entity mapping, and we talked about complex queries and how to handle complex SQL queries that you might get back from your DBA. So let's now talk about fetch types. Fetch types describe when Hibernate gets the association from the database. So in this case here, we have a many-to-many association from the author entity to the book entity, and this is a static definition in your entity mapping. It's part of your entity class. You can't adjust it. It's something that you define once and then use everywhere. And you can choose between lazy and eager fetching. With lazy fetching, the relationship gets loaded when you first use it, and it's default for too-many association. For eager fetching, it gets fetched immediately, whether or not you use it. And that is the default for to-one relationships. So my recommendation here is that you should use lazy fetching in almost all cases. That's the default for too-many associations, so please stick to the default. And we will talk about the lazy initialization exception in a second. And for to-one association, please check on an individual level. In most cases, you should change your fetch type to fetch type lazy, and especially set it to lazy if you're implementing a new domain model. If you're refactoring an existing one, sometimes it might be okay to use eager fetching, even if it's not that efficient. Yeah. Well, if you're using fetch type lazy, then, and I hope most of you do that, then you probably know the lazy initialization exception. That happens when you send a entity to the client and they give it outside of your current session context, and then someone tries to access the association. That is one of the issues caused by fetch type lazy. The second one is the so-called n+1 select issue, which occurs in this code snippet when we call the getBooks method. That is the same code as I showed you at the beginning when we had a look at the Hibernate statistics. So here, Hibernate now triggers an additional query for each author entity to get the associated books. And well, that's performance-wise an issue, because that's quite often the reason why Hibernate executes not only a few dozen, but in worst case, several thousand queries, because we're just iterating over a list of entities and Hibernate has to fetch all the associations. And there's a way to fix that. You can either use a fetch join in your query, or you can use named entity graphs or entity graphs defined via your API, and we will take a look at both options now. So the fetch join or join fetch clause is the simplest way to solve this issue. You can see that here the join fetch tells Hibernate in your select statement that it shall fetch the association, and the best way to show that is actually go into the IDE and take a look at it. This is the right test case. Okay, let's take a look at this test case and see what this join fetch. You can see it almost looks like the join clause that you normally use. So let's see how that affects the SQL statement. You can see the statement here, and you can see in the select clause that we're now selecting columns from the author table and from the book table. And you can see in the there. You can see in the from clause that Hibernate now joins the author with the book author, which is the association table with the book. So what this small change here, this additional fetch keyword does is it tells Hibernate to extend the projection, the path that we are selecting. It's everything here. And it tells Hibernate to not only select all columns mapped by the author table, but also all the columns mapped by the book entity. And to return the author entity, this one here, with an initialized list of books. So we now get all the information that we need with just one query, which is way more efficient than the approach that you saw at the beginning of this talk when we triggered an additional query for each author. And it ensures that by default, we will not get the books. The association from the author to the books is now lazily fetched, and we can be sure that we only get it when we need it. So to sum it up, fetch joins enable you to fetch a relationship within a query. So in this case, you get the author together with all their books. The disadvantage is that the join fetch clause is part of your specific query. So that means if you have a complex query with different fetching behaviors, then you need a specific version. Then you need a specific query for each of these use cases. And it creates a product in your result set, but that's just how relational table models work. The second option that I promised to show you is the named entity graph, and it's very similar to the join fetch clause. It was introduced with JPA 2.1, and the main difference is that you can define an independent graph of entities that shall be fetched with your query, and you can then use the graph with different queries or execute a query with or without a graph. So let's take a look at that. If we take a look at the author entity, you can see such a graph definition here. So I give it a unique name, and then I define the attribute nodes that shall be initialized with this graph. So I now tell Hibernate, when you fetch the author, please also initialize the books attribute. And the books attribute is this one down here. It's the one that maps the association to the author. So if we now run this test and instantiate the graph first, then set it as a hint, then you can see in the SQL statement that Hibernate does exactly the same as it did in the example before. The only difference is now how we define which associations Hibernate shall initialize. So there was a question if eager fetching makes sense to save database round trips when entities are not cacheable in the second level cache. Yeah, well, that depends. If all of your use cases need the associated elements, then yeah, you then might consider eager fetching, but that's almost never the case. You almost always have use cases that require an entity with a specific association, and other use cases that only require that entity and not the association. And in these cases, you should better use lazy fetching, because then you can define in your query or with a named entity graph that for this specific use case, you want to fetch the association and not in the other one. So yeah, how do you use a named entity graph? You can either use it as a fetch or as a load graph. And the only difference is how Hibernate handles the attributes not referenced in the graph definition. For other attributes are fetched lazily. For load graph, all of them are fetched with their defined fetch type. You need to be a little bit careful with this differentiation here. Until Hibernate 5.4.11, it doesn't make any difference which one you use. Hibernate always uses a load graph, but with 5.4.11, we finally get differentiation between fetch and load graphs. Not that it's that important if you take care how you define your association mappings, so always use fetch type lazy, then the load graph works totally fine for all. Okay, let's summarize this short chapter as well. So I first showed you the joint fetch clause and now the named entity graph, and both of them have the same goal in mind. The main difference is the definition of the entity graph. In this case, I showed you how to define it with a named entity graph annotation. The goal here is to define the graph independent of your query, which is, for some situations, the advantage compared to a joint fetch clause, because you can then define the query and execute it with or without a graph, or combine it with different graphs. Okay. Then Alex asked if we can use a graph with a JPA repository. Yes, you can do that. You can. There's an annotation in Spring Data JPA that you can use to add an entity graph to your query. You just add it to the method in your JPA repository. I'm currently missing the name of that annotation, probably entity graph, but I'm not 100% sure. If you check the documentation, then you can find it there as well. So yes, you can do that. Okay. Then let's talk about caches. The main goal of caches is to make sure that you don't fetch data multiple times if you can avoid it efficiently. So let's take a look at the host structure here. If we are talking about Hibernate sessions or working with Hibernate and a database, then most developers think of this. They think of a Hibernate session and a database connection and say, okay, this is how it works. We have a Hibernate session and it sends SQL statements to the database and gets data back. And that's not totally wrong, but it's a little bit more complex. So first of all, we have the first level cache. That one is part of the first of the Hibernate session, and it contains all the entities that you loaded within your current session. These might be dirty, which means they were changed, might contain uncommitted changes. So it's a good thing that the first level cache is specific to your Hibernate session and not shared with parallel sessions. Then we have the second level cache, and the second level cache is session independent. That means you can store entities in there that will be used by multiple sessions. And then we have the query cache, which, right, this diagram isn't 100% correct. The simplification that makes it easier to understand. The query cache technically is part of the second level cache, and it's Hibernate specific. But it's very different, and that's why I show it as a separate box in this diagram. So the query cache is the only cache that's Hibernate specific and the only one that stores query results. First and the second level cache store entities. Okay, so let's get into more details of all caches in the next few minutes. Let's start with the first level cache. The first level cache is the one that you don't recognize that you're using it, because it's activated by default and it's linked to the Hibernate session and used totally transparently. So whether or not you want to use it, whether or not you configured something, you are using the first level cache or the persistence context. And it contains all the entities that you use within that section. And Hibernate uses it to implement things like right behind optimizations, for example, making sure that not each call of a setter method for an entity attribute actually triggers an update statement. I mean, if that would be the case, then the performance would be so bad that we wouldn't be talking about it here, right? The Hibernate stores all the changes in the first, well, all entities in the first level cache. They can be dirty, and then Hibernate decides before it executes a query or at the end of a transaction, which entities were changed. And it does that by checking all entities in the first level cache and then writes the changes to the database. So yeah, this one is always used. And then we have the second level cache. The second level cache is the more interesting one because that's the one where we can actually do something. I mean, the first level cache is just there, does its thing, and well, it's one of the reasons why Hibernate works well. The second level cache is the one that we can use to fine-tune the performance of our application, and where we can either get huge improvements or totally break it. So let's talk about that in more detail. The second level cache is independent of your current session. That means if you put entities into the second level cache, then you can use it in multiple sessions that happen after each other or in multiple sessions in parallel. And you need to activate it, in general, in the persistence.xml file. And as the first level cache, the second level cache is used transparently. We'll get into more details about that in a second. And you need to be aware that the second level cache is not part of your persistence provider. That means it's not part of Hibernate. It could be Infinispan, it could be Hazelcast, it could be EHCache. There are various cache solutions out there that can be used with Hibernate and that work quite well. And if you want to dive into the caching details and configuration details, you need to look at these at the documentation of these caching implementations. Hibernate only defines the API to use the cache. So when you use the second level cache in the way that it's defined by the JPA specification, then you need to configure a shared cache mode. And the shared cache mode can have 5 different values, all non and unspecified. Let's ignore them for now. These are the ones that you would never configure actually. Because it doesn't make any sense to cache all entities. It only makes sense to cache entities that but for most cache implementations, you need to read an entity 9 to 10 times from the cache before you perform a write operation and invalidate the data in that cache. So you can only use the second level cache, or you should only use it for entities that you change rather rarely. And that means not all entities should be cached in your second level cache. And that makes the options enable selective and disable selective very interesting because that allows you to define which entities shall be cached and which not. I personally prefer to use enable selective because there you need to annotate your entity to make sure that this entity gets cached. And this is not as error prone as disable selective, which is the complete opposite. There you would configure something on the entity to prevent it from being cached. So yeah, I recommend using enable selective, and we'll take a look at the cache in a second. And by preparing that,
questions. Yeah. A lot. So first, the second level cache read only?
No, it depends on the concurrency strategy, how the cache gets updated. Well, you can use the second level cache in read-only mode, but most projects allow write operations on the cache, and that is the situation when it gets important that you have 9 to 10 read operations per write operation, because the write operations create an overhead that you then need to compensate with more read operations.
And Sam has a question. I wonder about the advantages of lazy fetching for pure REST API cases when the query result list is just serialized and sent back to the backend at the end of the session anyway. Does it still have benefits?
That depends. If your result list contains entities and you map it to a JSON document, how do you handle the associations to other entities there? If you always serialize the associated entities as well, so let's say you always send a JSON document of an author with a full list of all of her books, then you don't benefit that much from fetch type lazy. But well, first of all, that's not what's intended by REST API. And second of all, and that's way more important, doing that will result in a really bad performance because you're always loading lots of data from your database to then send a huge amount of data to the client and just tell the client, well, here's everything, do whatever you want. It's way better to design your REST API in a way that you just provide the information that you need. And for that, I would first of all recommend to not use entities and use specifically designed DTO objects instead. And if you're using entities, then you need to decide how to handle the associations. And these should still be lazy so that they only fetch if you need them.
Wonderful. Thank you, Torben.
More questions?
No?
Yeah, okay,
second level cache timeout recommended, question mark?
That's probably to remove entities from the cache after a while, or well, if that's the question, then I would recommend to take a look at the cache configuration. In my projects, we normally use an algorithm that's based on the least use approach. So the objects that you regularly use stay in the cache, and the ones that haven't been used for a while get removed if we need to clean up the cache.
Thank you, sir.
You're welcome. Okay, so let's take a quick look at the cache. What did I do here? I configured my cache to use enable selective. So I want to define which entities will be part of the cache. And then take a look at the author entity. You can see the cacheable annotation up here. That one is part of the JPA spec, and it defines, okay, this entity will be cached. You could also use Hibernate's proprietary cache annotation, which provides the same result. So it's totally up to you which approach you want to use. And well, if you're now fetching author 1 up here with entity manager find, and then down there with another entity manager find method, then we can take a look at the log, and we see here the statistics of the first Hibernate session. And there we can see that we had a miss and a put and one JDBC statement. So what's going on here? When we call the entity manager find method, then Hibernate tries to get the entity from the second level cache because we configured that this entity shall be cached. But where we just started up the application within our test case, so the cache is empty. And that creates a miss on the cache, as you can see here. So the only thing Hibernate can then do is to execute a query and get the record from the database. And after that, we put the record into the cache. So this is the miss that we see down here. And this is the put. And in between, we have the query. So up here, we just had an overhead with our cache, right? I mean, we had a miss on the cache that took a little bit of time, and then we had a put operation on the cache that also took a little bit of time, and then we have this JDBC statement that we had to execute anyways, even without the cache. We benefit from the cache in the second iteration. So now we have a new Hibernate session that would be the second call on your REST API. And you can see here that we now have no JDBC statement. So we didn't spend this time here and that time. We just got the entity from the second level cache. And you can see that here as well. Hibernate checked the second level cache, found the authored entity with ID 1, and then returned it. And that also takes a little bit of time. So that's also one of the reasons why you need a lot of read operations to make up for all the time that you spent putting the records into the cache, missing records if you expected them to be there. But a local interaction with the cache is way more efficient than a database query. So if you do that often enough, then second level cache is way faster than interacting with the database directly. Okay, so one other thing I want to show you is this one here. So I'm getting an author from the database, and if we then take a look at the right message, then we see that I now work with the books association, and the author entity is cached. If we take a look at the book, that one's cached as well. So if I'm running this test case that gets an author, works with the book association, and then does the same thing again, then we would expect that the second iteration doesn't trigger any database interaction, right? I mean, authors and books are in the cache. Why should there be any interaction? Well, the issue is both entities might be in the cache, but the association between author and books isn't cached. And due to that, Hibernate executes this additional SQL statement here in the second iteration, and you can see that query up there. That's the query that gets the book entities from the database. And if you want to avoid that, then you need to annotate the association with Hibernate-specific cache annotation. So that's not part of the JPA specification. This is a proprietary Hibernate feature. And by annotating your association with the cache annotation, you can then avoid this second, the query in the second iteration. And Hibernate now, see that here, gets everything from the cache. Okay, so let's summarize the second level cache real quick. You should always make sure that you only cache entities that are read very often, but only rarely changed. You can do that then by setting enable selective in your persistence layer, in your persistence.xml. Define which entities shall be cached and make sure to cache the association as well. And then Hibernate will use the cache for all entity manager find calls and whenever you traverse an association, but not for JPQA queries or criteria queries. If you want to cache these queries, then you need to use Hibernate's proprietary query cache. And this one stores query results in a session-independent way and is officially part of the second level cache. The thing is, caching queries is even more complicated and can be used even less frequently than the typical second level cache because Hibernate has to invalidate all records in or all entries in the second level cache whenever something in the underlying tables changes. And due to that, you need to activate the cache first of all in your persistence XML by setting the hibernate.cache.useQueryCache parameter to true, and then by activating the cache for the specific query. And then Hibernate stores the query result in the database. And then you need to be aware of a second pitfall, and that is the query cache only contains references to entities. So you need to make sure that the entities that you return in the cached query are also cached in the second level cache. Otherwise, it might happen that you cache the result of a query that returns 100 entities, and Hibernate tries to resolve it against the first level cache, doesn't find it there. Then it checks the second level cache, doesn't find it there. And then it needs to get the entity from the database, which means it triggers a query that fetches one record from the database. And in worst case, it does that for all entity references in that cached query result, and you replace one query that would have fetched 100 entities with 100 get by ID requests, which obviously is a bad idea. So please make sure whenever your cache query returns entities that you also cache the entities that are returned. Then quick look at the query cache. So I activated it in the persistence XML, and then I'm using here Hibernate's query interface, and I set the set cacheable attribute to true, and that tells Hibernate to cache the query result. And you can see the result here. We have a select statement, and I activated caching for that. And then I write out the author entity. That's the thing that happens here. And if I then trigger the same unique result method again, Hibernate would normally trigger another query, but you see there is no additional query. Hibernate gets the query result from the second level, from the query cache. And you can see here with these two puts that Hibernate stored the query result and the entity for this author in the second level cache, and got it then from there for the second iteration. Okay, so let's sum this up for the query cache as well, or all caching topics in general. Please always make sure that you only cache data that is not changing too often. So configuration data, product catalogs, everything that's relatively static. As I said, you need about 9 to 10 read operations per write operations as a rule of thumb, of course, and always depending on the cache implementation you're using and the overall structure of your domain model. And well, the next thing you should always do is to benchmark the application before and after changing anything on your cache. That means before activating it or before changing the existing configuration, because caches can cause side effects. In general, caches, first of all, create an overhead. And you then need to make up for that overhead by reducing the number of database queries. And you always need to check, well, do we actually achieve the performance improvement that we expected? And the only way to do that is to do a benchmark before and afterwards. And please check the whole application just to avoid side effects or to find side effects before you deploy it to production. And then you always need to make sure to that your query cache matches the second level cache. So that means that if your query returns an entity, then it also should be cached in the second level cache. Okay, and yeah.
You used a deprecated couple of methods. Have they been replaced by anything, or?
No, there's a very similar interface that you could use as well, and where the methods are not deprecated. The second level, no, the query cache is there and there to stay. So you don't need to worry about any removals of APIs there. Okay.
Wonderful.
And with that, I've reached the end of my presentation, and I'm now open for more questions. We have a few minutes left. Marcus, do we have any questions? I see a lot in the chat. You probably have something for me.
It's been comparably active. I did answer a couple of in between, and Thomas has one last one. Do we have to be worried about the deprecation of the old Hibernate criteria API from 5.2? Will it disappear soon? Do you know that?
Yeah, you definitely need to worry about that. I mean, I'm not part of the Hibernate team, but from all I've heard from discussions with the Hibernate team and what I've seen in Hibernate 6, the old Hibernate criteria API will be removed in Hibernate 6. That's the current situation. The reason is relatively simple. The Hibernate team changed the whole query creation within Hibernate. So up to now, there are several places in the code that take care of the query creation. So creating a query for Entity Manager, fine, for JPA queries, for association traversal, all these kind of things. And with Hibernate 6, they're introducing a semantic query model that's used by all places that need to trigger a query. And then they create an abstract syntax tree out of that semantic model. And from that, the query statement itself. So that's just a very simplified description there. And that requires a lot of changes internally. And there it seems like they decided that they will not implement all these changes for the old criteria API, which has been deprecated for ages. Yeah, if you're using the old Hibernate criteria API, then you would need to migrate to the JPA criteria API. I supported a few teams doing that as a freelancer, and that's not too complicated in most cases. Well, in almost all cases, it works pretty well. The issue always is the amount of code you need to change, and you need to check how you define your entity mappings. If you still use the old Hibernate XML mapping, so not the JPA compliant one, the really old Hibernate XML mapping, then I would recommend that you update that mapping as well, because it behaves differently with Hibernate's criteria API and JPA's criteria API, because some defaults are different there. And keeping the old mapping definition makes your code really unpredictable. So technically, you don't need to migrate, but I would highly recommend.
Wonderful. So if in just looking at the time right here, we're almost on top of the hour, so I guess we're going to cut it short for now. I just want to make sure if we have not answered all your questions so far, please make sure to follow me on Twitter. My DMs are open. You can also follow Torben on Twitter. Your details are on the event landing page, and this is exactly where the recording is also going to go. And I guess Torben is going to open source the slides somewhere or publish them at least on SlideShare or wherever. Can you tip next slide for me, please?
And, sure. And if anyone has questions, feel free to reach out to me on Twitter. I posted my handle in the chat, or visit me tomorrow on my YouTube channel to discuss more questions. I would do a regular live stream there.
Exactly. Yeah, no worries. As a matter of fact, if you're interested in a couple of more product-related resources, looking for a data grid because you're looking into distributed caching or stuff like that, just go to the events side. There's collateral listed, and you can just download and take a sneak through. And just one last tap from you today, Torsten, please. Torben, Jesus.
Yes.
Me and names, that is a famous thing. It's a DNA deficiency, just while everybody's wondering. So we're going to continue this series in July. It's probably going to move places from developers to another property on redhat.com. We're going to have way more exciting content around software development in general. I'm going to look a lot more into containers together with you. If you have ideas or questions or suggestions for upcoming webinars besides Quarkus or any kind of microservice approach, just let me know. You can reach me at marcus@redhat.com. So just fire your emails at will. Torben, thank you so much again. It was a pleasure having you here today. And I hope we can probably line you up for What's New in Hibernate 6 webinar at some point. Thanks everybody for listening, and see you soon in July. Stay healthy. Check back on new webinars upcoming soonish. Thank you.
Yeah, it was my pleasure. Thanks for having me. And if there are any unanswered questions, feel free to reach out to Marcus or me on Twitter.